equal to 40 log 4. Whatever that is. 55.45 days. Let's see here. So I guess that means we need to add it. It depends on how you, I mean, should we add it at the start of the 55th day to be safe? Depends on how exact this study, judging the.
Rebelling until halfway through the.
That's right. I guess you got.
Start rebelling until lunch.
Until, yeah, you got to, exactly, before lunch. I think that's good. That's a good. We're assuming the children drink Kool-Aid for breakfast. I'm willing to accept that. Yes.
Would it be easier to assume that this camp is actually a cult and it kills the children before?
Is the camp actually a cult? Let's see here. I don't know. I'm not looking to edit this video, so I'm not going to comment. Oh, this one I can do. I just didn't have time. I mean, so I'm thank you for your help on this one, guys. So I do hope you guys did this one. This one just is a matter of straightforward calculation. So you ought to be able to do this. It seems very likely I would ask that kind of question on the test somewhere. All right, let's try it out. So we were supposed to calculate, what was it? L1, L2? And we act on a function, all right? So what is L1? What is L2? L1 is x squared plus d. What's L2? X squared d squared minus 1, like that? Or? Okay, cool. So the way this works is we have L1 of L2 acting on f, which is x squared d squared acting on f minus f. All right, let me do another step here. This is x squared plus d. And let me rewrite this in a way that's more familiar. So this is x squared times f prime prime minus f, right? So we add operators, right? So this is x squared times x squared f prime prime minus f plus the derivative of x squared f prime prime minus f. And let's see here. So that gives me x to the 4th f prime prime minus x squared times f. And I had to do product rule here because the derivative is hitting x squared times f prime prime, right? So I have to think product rule. And so that's plus 2x f prime prime plus x squared f prime prime prime, and then minus f prime. That f just differentiates to f prime. There's a product rule, and then there's the f prime minus lonesome there. And at that point, I need to clean things up and try to make it prettier. So there's an f everywhere here. We can pull it out. We've got x to the 4th plus 2x times d squared. Let's see here. Plus x, I mean, I'm going to write it in a particular order. You might have written it in a different order. That'd be fine. X squared d cubed. So let me just underline what I've gotten so far. My order here is by no means sacrosanct. I mean, it's just, I just picked an order. It's not that revolutionary or anything here. This one, and I also picked up, I'm just grouping the d squared terms together. There's only one d cubed term. And what am I left with? I'm left with, you know, minus d, and then minus x squared. All of that, x on f. But this holds for arbitrary functions, so it follows that L1, L2 is equal to, I'll rewrite it, x cubed, d cubed, plus x to the 4th, plus 2x times d squared, minus d, minus x squared. So there's L1, L2. Should I calculate the other one? Probably I should. L2, L1. It's nastier? Well, then I want more room. Maybe I can do it down here. L2, L1, acting on F. X squared, D squared, minus 1. L1 on F is exactly X squared F plus F prime. I'm going to hurt my neck. So that is X squared. Oh, great. Googly moogly. See what you guys are talking about. Yeah, I see what you're talking about. 2x F plus X squared F prime. Minus X squared F minus F prime. So that's X squared parentheses 2F plus 2X F prime plus 2X F prime plus X squared F prime prime, close parentheses, minus X squared F minus F prime, also known as Oh. Oh, wait a minute. No, I got it over here. Oh, we got an x to the fourth this time, eh? So we got x to the fourth d squared. So I'm taking care of this one first. Next, I'll pick up the derivative terms, which looks like to me I've got a 4x cubed. 4x cubed minus 1 d. Those I'm picking up right here and also over here like so. Then I got my constant terms. I got a plus 2x squared. You know, this is actually kind of relaxing. I'm enjoying this. I mean, I should do this more. We should just calculate operators every day. I think I could get used to this. I mean, this is. I think those are the same, right? So that just gives me plus x squared rather than plus 2, because I subtract the one copy after from it. So if I haven't made a silly error, this is your L2, L1.
In the first one, in the L1, L2,
Yeah.
your answer, you have x cubed d cubed, but in the one above that, you have x squared d cubed.
Oh, thank you. Yes, we should fix that. Estos. Now, I told you guys that if I was to ask you a Bernoulli problem or a substitution problem, I would give you the substitution, right?
Yes, that is what you said.
So, here, I'll show you the one. What did just that? Sorry, my computer's being funny. Let's see here. Where's that stupid thing? The ones in red are the ones I didn't actually assign to you. Come on. Where'd it go? Did I delete it? Oh, well. I'll show you that one anyway. You know what? I'm skipping. I mean, I just have to look here real close. I'll find it. Come on. Is it at the end? Oh, here's one. Yeah. It's at the end. So I almost assigned you guys this one because I thought that would be a good problem to work. So what's this? How would you solve that? This one you don't need substitution or anything fancy. This is just a plain old garden variety separation of variables problem. But to do it, you need to factor the y. You need to use partial fractions in the y variable to solve it. If you don't know partial fractions, it would be a good exercise for you to work through this. Come on. I can't find the problem oh, there it is. The other one I thought might be instructive is just this generic sort of problem. I give you a differential equation, like in this case y prime prime equals to 2x times y prime squared, and you can solve it by making a v equals y prime substitution. Now this is a second order differential equation, right? So it's going to require two integrations this time. You put the v in, you solve it, right? Then you would integrate that to solve for y. So going back to your comment earlier, much the same.
Will you post the additional 12 problems we didn't get on Blackboard, can you, so that we can have them in practice?
Sure. You're not going to ask me for solutions, are you? Okay.
If you feel like working them out, we should post
No pressure.
It's not like you assigned us a quiz like 2 days before it was due or anything.
I let you work in groups. I let you work in groups.
Only helpful if other people know more than you.
But yes, I will post the rest of the problems in their unedited glory. Yes.
Will 25 be on the PDF solution? The solution